Hello and welcome back. Let's finish off our discussion this week with test-driven development. So we'll finish off with a little bit more around testing foundations and a particular sort of development cycle called the test-driven development cycle. All right, so to start off, we need to make sure we actually understand what TDD or test-driven development actually means. And it is a cycle in which we are writing our tests before we're actually writing our code. So we have sort of pared it down to this idea of red, green, refactor, where red means the first thing that we do is we write a failing test. So allowing us to sort of define the desired behavior, but we know it's going to fail because we have not written the code yet. So we literally will write a test knowing it will fail. We run it, it's red because it's failing. Then green is step 2, where we actually write the code to make the test pass. So you write the simplest amount of code that will now ensure that your test will pass, like in the purest form of TDD. And then step 3 is refactor. And this is where we clean up our code while ensuring that our test stays green. So of course, there isn't going to be very much to clean up after we write one test like this, or even 2 tests like this. But maybe by the time you've written your 50th test like this, you realize a big refactor can happen and a bunch of stuff can move around and different methods can be helpful and stuff like that. And so we do a big refactor. And we know that at this point everything was green, and doing the refactor should keep everything green. And we just continue this cycle of red, green, refactor as a way to define our behavior, write our code, keep our code clean. Now this idea of TDD does encourage ensuring that we are designing our code so that it will be testable, because we have to. We're writing our test first. It forces us to think about how the code's going to be used well before we write it, right? We're asking ourselves, okay, well, what are the behaviors that we need to come out of this code? What are the ways in which this method is going to be interacted with? And what should be the expected result, right? And then we're writing tests to validate for that. It often will lead us to cleaner, more modular, and more maintainable code. And it also will keep us in line with one of the many acronyms we're going to learn, which is YAGNI. You ain't gonna need it. YAGNI is one of my favorites because we're sort of writing the simplest version of our code every time. Now, if TDD sounds very like tedious to you, you're not alone. Purist TDD could be very tedious to write, but really what this is about is keeping in mind different strategies in which we can sort of write better, cleaner code. So even if you don't see yourself ever doing really intense TDD for a really big, complex project, it's certainly something that you can use or modify it to use throughout your project or future projects. So let's just take a quick look here at a walkthrough of a TDD piece of code. So the very first thing that we're going to do is we're going to talk about validating passwords. And we're going to validate some passwords using this test-driven development. So test 1 is that the password's too short. So we know that the password requirement for our program is, I can't remember, 6 characters, whatever it is, which means if we pick a password that's too short and we try to run a test for it, it should fail. It's going to fail because right now the code doesn't exist, right? We haven't tested for anything right now. Maybe it always returns true. Like the is valid always returns true, and we know that this is too short. It shouldn't come back as true. So assert not valid, not is valid, it will come back and this test will fail because we haven't tested for it yet. So, it was 8 characters. So close. So what do? Now we go from red, our failing test, to green, which will be now taking our is valid code and actually testing that the length is greater than or equal to 8. And now we'll get our green test. The next thing that we're going to, and then refactor, right? But there's nothing to refactor. It's one line of code. It's fine. The next thing we do is we write our next test. Our password requirements involve at least one uppercase, right? So here we're going to call is valid again. We call is valid on all lowercase, the word lowercase 8. This should fail. But as we can see, if we look over here at our test, return the length being at least 8 characters. This is like 10 characters, maybe 5. Yeah, 10 characters, so that'll come back as true. But we wanted false. We needed to assert that it was not valid because we needed an uppercase, right? So this also will fail. So here's the red of our TDD cycle. What do we do next? again, this is just in Python, but we can see we can do our return length is this, and any of the characters needed to be an uppercase. So as long as at least one of them is uppercase, this any call will return true. As long as it's greater than or equal to 8, this will return true. This will give us true, and true would be true. Now this test will pass because this will return false, because none of them, this is an any, none of them will be uppercase. So this returns false, this returns true, true and false gives us false. We're going to return false. Our test is going to pass. So we can see how we've got this red and green going on, and as our code becomes more and more complicated, we start to enter into that refactoring step as well. So each test effectively is exposing a missing requirement. So we have our list of requirements, we have our list of things that we want to make sure that we have to make a password valid, and each of our tests should be exposing a situation in which our code would fail. And this way, our code is evolving gradually. It's evolving with confidence because we know we're hitting each of the requirements very targeted, each of our tests. We're not just sort of figuring it out as an aftermath. And we also get to grow with confidence knowing that our tests are staying green. So even when we do a refactor after, we know we had working code, we should have working code after. That means in this scenario here, perhaps this 8 should really be a constant, right? It shouldn't just be an 8 plugged in there. It should be a min length variable of some kind or a min length constant. So as part of our refactor, we can put that constant in, rerun our tests, and it should still be green. And as long as there's no spelling mistakes and it's not being used somewhere else, whatever it might be, we're still going to get a green test. Plus that means that in the future, if somebody goes and changes that min length to 2, I don't know, right? And then they try to run the test, this will fail, which now means they can actually go into your code base and go, oh, somebody else was relying on this constant value being the value that it was. I shouldn't have just gone and changed it to a 2. I didn't realize I was going to affect other parts of the code. So by writing this code as you're going, we're really creating this really stable, maintainable code base for the future as well, for future iterations, for people to try to, reuse pieces, stuff like that. So when exactly does it work best? It doesn't work for all situations, and that's okay. A lot of this class is going to be stuff that doesn't work for all situations. But when we have clear testable logic, so business rules have been given to us, or validation logic, right? Or we're transforming data from one type of data type to another, or one format to another. These are great examples of when TDD will work really well. It can help us ensure we're hitting our boundary cases properly, that we're parsing exactly what we want, that we're calculating the right pieces of information. So anytime we're doing our logic, TDD actually makes a lot of sense. It doesn't really make sense when we're writing our data objects that are just a bunch of getters, right? It doesn't really make sense when we are writing our transactions for the database. But those business and validation rules, it can be very helpful. It's also really helpful when we're talking about small modular functions, right? It thrives when our code is broken up into these teeny tiny units. So when we're actually writing our code and making those variables and making sure those pieces are there, we're making it in a way that allows it to be reused in other places. Plus, we're ensuring that if somebody tries to reuse something and then change it, it will break the tests. If they change something that we're relying on, we have tests that makes sure that the code that we rely on functions the way we expect, right? So this idea of TDD really helps us create some confidence in our code base. It also encourages our team collaboration, right? When you're writing your test first, we are having to clarify the requirements and expectations ahead of time. We have to have that discussion with our teammates so we know that we're all headed sort of in the same general direction. It also allows us to avoid misunderstandings between our future developers, what the testers are looking for, what the stakeholders are expecting. It really can help us focus on achieving the same unified goal, right? Really enhancing that collaboration. Now, when does it not work super well? A couple of situations here, and they all may come up. UI heavy code. So if you have a really simple application, but what really matters is the UI, for example, like my Monster Buddy application, TDD doesn't work very well there. It just doesn't make a lot of sense. There isn't a lot of validation that happens in my Monster Buddy application because there's nowhere to really put any input. It's more about the visual act of things happening that calm my child down. So maybe TDD isn't the best approach for developing my app. If you're doing spikes or prototypes, so the whole point is to make something quickly and just fail fast, TDD is not going to work because it is slower. It is a more meticulous design process. And then, of course, it's not going to work well in the poorly defined requirements area. It's really important we know what you want, because if I don't know what you want, I can't design tests for it. And sometimes that's what happens. Sometimes you're working with a client and they have a general idea of what they want, but they're not really telling you all the pieces because they don't know, they don't have the right language to describe it, whatever it might be. And then doing TDD might just be a waste of your time because a bunch of it ends up getting scrapped or changed later anyway. So really sort of understanding the paradigm in which TDD is helpful helps kind of shape recognizing this is a really good time to sort of pull that development cycle out of your toolbox and use it. Now, of course, there are some common pitfalls that we want to try to avoid or at least be aware of while we're trying to write these tests when we're sort of focused in on this test-driven development cycle. So if we write tests that are too broad, this isn't really going to work. The whole point is clean, simple, small tests. So it really is about not just sitting down and saying, I have a method, I'm going to write some unit tests. That's not the same thing as actually doing test-driven development. And we can't write a 20-line test and say, well, this was test-driven development, right? They need to be small, clean, and simple. They're focusing on a single behavior, and we really need to avoid covering too much in a single test. Unit tests, if you remember our testing pyramid, they are intentionally small, numerous, and fast. So it's okay to have lots of them. That's a good thing. We don't need to try and squish it all into one test. The next is skipping the red step. It's really easy for us to just go, yeah, it's going to fail, right? But the point is, one, practicing what we preach, right? We want to actually practice it properly. We want the dress rehearsal to be just like the real thing, because as code gets more complicated, it's not so easy to know that the error you're going to get on the red step is what you think it is. Maybe you won't even get an error and you were expecting red. Why did that happen? Who knows? But these are the questions we want to be able to ask. We get feedback in that red step. Now, in the initial beginning, start of doing TDD with a single test and a single line of code, we can see why skipping the red step feels so, it feels appropriate, right? Like, who cares? It's one line. But the reality is, in the long term, we need to be in the habit of not skipping that red step because we do actually get feedback from it in more complicated situations. The next is this idea of over refactoring too soon. Make sure it passes first, then we clean it up second. Very often, what we'll do is we'll go into our code base, add our line of code, and then immediately realize, oh, we could clean this up and move all these things around, and then it would just look so much better. But there is actually a method to the madness of red-green refactor. Make sure you get that green, and then go and do the refactor. Getting the green first ensures you're getting the desired behavior, and you are basically giving yourself a baseline, saying, all my previous code is working still, my new code is now checking and working as I expect. Now let's refactor and see what the heck we can make cleaner, right? Without breaking things. But if we skip that green, or not even just skip it, but try to do the refactor and then we'll run our test after, we could break other things. Things can get really confusing. We want to kind of avoid doing that. The next one is ignoring our test readability. Tests should be considered the same thing as documentation, just like comments, just like writing a README. They should be easy to read. Don't forget that having clear names allows somebody else who comes in to read the code to know what's going on. Using that arrange, act, and assert structure is going to allow our test to look exactly as we're expecting and have the right feel as expected. And if you have a team member who maybe isn't following this, it's a good thing we're going to do code reviews, because you can remind them that they need to be having that arrange, act, assert structure, or that variable name of user temp isn't going to be good enough. Lastly, we have only testing happy paths, right? And this is a very common pitfall. We can't forget to test our edge cases, our invalid input, our error handling. We have to test many different scenarios. I talk a lot more about the different scenarios and like how we can categorize different testing conditions in software engineering too. But it's still important for us to think about it here. So we can think about things like what makes a method return true. And then what should happen if it would return false, or what makes a method complete successfully, what should happen if it is unsuccessful. We need to catch those edge cases, those invalid input, random explosion errors, right? We really want to think about all those different things, and if we only test happy paths, we will surely find ourselves in a situation in which our code explodes and the user, us, we have no idea why, right? If you're not confident breaking things without fear, you're not doing TDD yet, right? So that's that last line at the bottom there. What does that actually mean? Well, what we're saying is if you are nervous to make changes in your code because you think you're going to break things and you're nervous about getting back to the previous state, right? You're nervous about breaking it and then not knowing how you broke it or what happened or what went wrong or whatever, then it's not really doing TDD just yet. All right, so here I have a really nice table where we can see test-driven development on one side and we can see testing after we wrote the code on the other side. And again, I'm not saying one is more valid than the other. Just depends on the situation. Now, TDD is when we write our test before, testing after is when you write your code and then you write your tests for your code. TDD allows us to guide the design from the start, whereas in the other scenario, tests really adapt to the finished code. Once the code is done, we write tests based on what we see, right? More of like a white box testing kind of scenario. When we're doing TDD, we get this immediate feedback on design flaws in our code. We find the immediate feedback on things that maybe are interconnected but we didn't realize. When we go and test our code after, some bugs might just go unnoticed longer because there may just be some more intricate sort of connections that we didn't really realize when we wrote the code, and we didn't catch them when we wrote the tests. TDD helps encourage the small testable unit structure that we're always looking for. Testing after the code, it doesn't necessarily mean this is what's going to happen, but you do risk sort of more tightly coupled code and harder to test code if you write code first, write test second. Test-driven development gives us those constant checkpoints, and it honestly shapes better code, not just, does a quick check after. Tests really are the backbone of our product. They are the backbone of your development because they're what you can show to businesses and to management and say, this is why you can have trust in my project. This is why you have trust in what I've built for you, right? So a lot of us sort of treat testing like an afterthought, but the reality is when it comes down to dollars and cents and what a manager wants to see and what a CEO wants to buy into, right? Like they need to know with full confidence that they can trust your product, and a well-designed test suite helps them develop that sense of trust. So as part of our pause and reflect, I have this little exercise for us to do here. So you take a pause here, use some test-driven development, and write some tests and implementation for one of the following functions. So just sort of pretend that you're writing this code out. You can do it by hand, or you can do it in Java. That's fine too. It's a good way to get practice with JUnit. Either do just like a basic convert Celsius to Fahrenheit, or you have an array of scores. Pretend it's like an array of scores for a classroom or something. All the students are in the array. It's a full array, and then an int n. And n could be any number, and you need to pull those top n scores from the array of scores. If you're looking for a simple, basic understanding of test-driven development, convert Celsius to Fahrenheit is a great place to start. If you're looking for something that will involve a little bit more refactoring long-term and really digging into the helpfulness that TDD can bring us, the get top scores example will definitely take you further. I recommend doing the first one and then the second one, right? I think you could probably, as third-year students, do both within like an hour, maybe two, if you don't remember all your data structures. And then once you've completed these, take a second and reflect, right? That's part of this. What changed in your approach? Imagine for a second if you were to have done it the other way. Did we catch things that maybe we wouldn't have caught before? Did we have our initial thought and our final product, and did they look different from each other, right? Did one have 4 loops and one not? Did one have parsing and one not? Who knows, right? So really taking that chance to reflect is how you're going to sort of build out your toolbox of things that you know you might be able to use in the future. Cool. So there is an optional video added on to this regarding Git if you're looking for more information and you want to sort of get a little bit more of a feel for it for Git, as we did talk a little bit about version control earlier in the week. But if not, I'll see you in next week's videos. Thanks, everyone. Bye.